Hi, my name is Hazi, and I will explain to you about benzene structure. What is benzene structure? Okay, before that, I want to tell you about a little bit history of benzene structure. Benzene was isolated by Michael Faraday in 1824. 1825. Okay, benzene. Benzene formula is C6H6, indicate high degree of unsaturation. Its formula has no relationship with alkene and alkynes. As a structure formula that involves a 6-membered carbon ring with 3 double bonds are present. This structure is one of 2 equivalent structures that can be drawn. This and this of benzene that occur only in location of double bonds 1, 3, 5 position versus 2, 4, 6 position. Experimental evidence indicates that all of the carbon-carbon bonds is benzene are equivalent, and this structure implies 3 bonds of one type double bond and 3 bonds of one type different type single bonds. Correct bonding structure for benzene is an average of 2 arene structure. This average structure situation is the concept that electrons associated with the ring double bonds are not held between specific carbon. Instead, they are free to move around the carbon ring. Placing a double-headed arrow between the conventional structures that are averaged to obtain the true structure is one way to donate the average structure. The compound can be considered aromatic in 3 rows. First, it must cyclic and planar. Second, it must conjugate system in it. And 3, it must follow Harker's rule, which states that the number of pi electrons equal 4n plus 2, where is an integer 0, 1, 2, 3 and so on. The compound which does not follow these three rules are called non-aromatic compounds.
Hi, Assalamualaikum. My name is Muhammad Amir Farid bin Ahmad. Today I will explain about the nomenclature of the benzene derivative. There are 3 types of benzene derivative. First is the monosubstituted derivative. Second is the disubstituted derivative, and the third is the polysubstituted derivative. First, the monosubstituted derivative of benzene has only one substituent in the compound. The example are the chlorobenzene, the nitrobenzene and the ethylbenzene. The chlorobenzene, the chloro acts as the prefix or the substituent of the compound, and the benzene acts as the parent of the compound. Then, if the substituent of the benzene is the larger than the benzene ring, more precisely, the substituent has more 6 carbon atoms in the compound, so the benzene ring automatically acts as the substituent, called a phenyl group. The example is 1-phenylheptane. The phenyl group often indicated by the letter of pH, or sometimes it it indicated as the AR, or it means the aromatic ring. It has two substituents in the compound. It called as the silane, and there are three constitutionally isomeric silane, such as the orthosilane, or called as 1,2-dimethylbenzene. The second one is the metasilane, or it called as the 1,3-dimethylbenzene. And the thirdly called as the parasilane, or the another name is the 1,4-dimethylbenzene. These isomers differs from each other by the relative position of the methyl group in each carbon atom, and can be named in two ways. First, using the descriptors such as the ortho, meta, and para, or it can be named using the locants such as the 1,2-dimethylbenzene or 1,3-dimethylbenzene. Lastly, the polysubstituted derivative of benzene is called when there are three or more substituents exist in the compound. For the important note, the descriptors like ortho, para, and meta cannot be used in this type. There are four types in naming this type of derivative. The process in naming is same like the naming in the alkane, alkene, and alcohol. First, identify and name the parent. Second, identify and name the substituent. Thirdly, assign a locant of each substituent. And lastly, arrange the substituent according alphabetically.
Okay, hi guys, I'm Amar. Okay, I will explain about Harker's rules. Okay, what is Harker's rules? These rules determine if a planary molecule will have aromatic properties. These rules stated that if a cyclic or planar molecule has 4m plus 2 pi electrons, it is considered as aromatic. There's four criteria that can make them for There's four criteria for aromaticity. First, the molecule is cyclic, which is have a ring atom. Second one is molecule is planar, which is the atom in the molecule is the same in the same plane. The third one is the molecule is fully conjugated, which means p orbitals at every atom is full, which is have all four attachment is full. The fourth one is the molecule has 4m plus 2 pi electrons. This can be n equal to 0 or any positive integer. How we can tell which electrons is pi electrons? Okay, first, pi electrons must be in p orbitals or sp2 hybridized atom, which is have 1 p orbitals each. It means the molecule is fully conjugated, like I said before. And the easy way if the molecule have 3 attachment of atoms and a lone pair of electrons. Let's start with aromatic example. The first one is aromatic, which is there are 6 pi electrons and the n is equal to 1. So as you can see, the attachment is all conjugated, but not the top. That's why they have 6 electrons and n equal to 1. Next, the second one is not aromatic. This one is not fully conjugated, and the top carbon is sp3 hybridized, which means not Hb2, sp2. It's not fully conjugated, and the top C is sp3 hybridized. It's not sp2, which means they have empty attachment, so there cannot be any related to aromatic. That's all for me. Thank you.
Electrophilic aromatic substitution. From the word substitution, we actually replacing one of the hydrogen with bromine. word aromatic because we dealing with benzene ring. Electrophile is a substance that want electron so bad. If electrophile react with benzene, one of the electron in benzene will go to the electrophile and one double bond will be lost. When electrophile get the electron from the benzene ring, they become neutral and will attach to the benzene. Benzene will lose one electron and will have positive charge on the top carbon that lost electron. Next, a base will grab the hydrogen that attached to the same carbon that electrophile attached to. The electron from the hydrogen will go to the positive charge in the benzene. The double bond will generate again in the benzene and this make benzene stabilize again. Benzene become aromatic again.
Assalamualaikum. My name is Muhammad Arash and today I'm gonna talk about halogenation and nitration. This mechanism is for electrophilic substitution reaction between halogen and benzene. Halogen such as chlorine and bromine for halogenation, and nitric acid is for nitration in the presence of FeCl3 and FeBr3 and H2SO4. As for general mechanism, the first step is benzene will react with electrophile and behave as nucleophile attack in the electrophile. Okay, this is gonna be an addition step where it's gonna be slow reaction because benzene losing its aromaticity where from the stable compound to unstable compound. This is also an endothermic reaction because the molecule with low energy to the high energy, that's why it's slow. In the second stage, a base is going to take hydrogen and regenerate the aromatic ring. This is called an exothermic reaction, and it's fast because it goes from unstable compound to stable compound. So the hydrogen is replaced by the electrophile. So this is called an electrophilic aromatic substitution reaction. Okay, in halogenation, we react with chlorine and benzene in the presence of catalyst, which is FeCl3. So the first step is the molecule of chlorine will react with the catalyst, which is FeCl3, that will produce a product which is iron chloride. Benzene ring will attack the chlorine with a positive charge, and chlorine will attach to it. So the benzene will get a sigma complex, which is a carbon cation. Okay, the next step is the base is going to react with the hydrogen and regenerate the benzene ring, and we're going to get the chlorobenzene as our product and acid hydrochloric as a side product. In nitration, benzene is going to react with nitric acid and acid sulfuric as our catalyst, and we're going to get the nitrobenzene as our product. For the nitration, the first step is nitric acid will react with sulfuric acid to generate the electrophile, which is the nitronium ion. Then the nitronium ion will be generated where a nitrogen atom have a positive charge. Okay, so the benzene ring will attack the nitronium ion, and the nitronium ion will attach to the benzene. So this will give the benzene ring a sigma complex, which is a carbocation. Okay, so for the next step is the base is going to react with the hydrogen and going to regenerate the benzene ring. So the product we get is a nitrobenzene, and a water is a side product. Thank you.